First of all, my name's Helen Gavin. I'm based in the Environmental Change Institute of the University of Oxford, working on the programme on integrating renewable energy. And I describe myself as a sustainability professional working across consultancy and academia with expertise in renewable energy and water resources. Now, our two expert speakers today are leading voices in their field of power systems, Malcolm McCulloch and Eric Brown. Now, Malcolm is an associate professor in engineering science and group leader of the Energy and Power Group at the University of Oxford. And he has many interests in the domestic energy sector. He looks at the user-centric demand-side management technologies and information to enable behaviour change. In the transport sector, his research examines powertrains for electric vehicles and how they can be used in the decarbonisation of the electricity grid. And in the area of energy for development, he's developing technologies to provide cost-effective and small grid solutions that can provide a pathway to electricity for all. And the many spin-out companies have been formed from his work. Now, Eric Brown is the Chief Technology Officer of the Energy Systems Catapult, and he provides expert insight and guidance on cutting-edge energy sector innovation, both internally and across a range of external advisory bodies. And prior to this role, Eric was the Innovation Director of the Catapult. Now, Eric combines an electrical engineering background with many years of experience in the telecommunications industry. And he's particularly interested in the use of information and communications technology, or ICT, to enable and support the evolution of energy systems. So, time for me to stop talking. I'm going to hand over to Malcolm and Eric, who will now speak for about 35 minutes before we go to the Q&A. So please pop your questions and comments into the Q&A and we'll pick them up later. Thank you.
Thank you very much, Helen, and thank you to everyone who's joined us this morning. We're very pleased to see so many people interested in the subject of net zero. So net zero, just for those who want to have a sort of reference definition for what we mean by net zero as we speak about it today, is and in the UK it has a particular meaning, so we'll use that, which is that by 2050 we'll have net zero greenhouse gas emissions. Now, in other countries they use different language to describe their objectives for addressing climate change or the impact of climate change, but we all share the intent and sense of urgency about needing to do so. Malcolm and I have a shared commitment to addressing the challenges of climate change, and we also have a shared interest in how systems engineering might help us to achieve net zero. So we're pleased to have the opportunity today to share some ideas and to exchange some ideas with you on that subject. And I guess the poll suggests that we have a group here that's interested in both areas and how they might come together. So with that, I'll turn over to Malcolm, who'll give us some context. He has a very interesting way of framing it, and we'll start with thinking a little bit about how this all fits together. Malcolm.
Thanks, Eric. So what I tend to do is try and look at I'll start by looking at a very high level perspective. And at an extremely high level, you can think of that we have the environment which provides us with a lot of resources, and we can think of environmental capital providing those resources. And some of those resources are things like coal, but also water, food, and other key flows which are absolutely critical to both maintain and to grow our societal capital. As a society, we then use those resources to not only do things like provide this internet, but we also do some unexpected or unintended consequences, which is produce waste. That waste can be in the form of, for instance, the CO2 burned to be able to have this webinar, all the way through to solid waste and also to waste that goes into the oceans. That basically then provides a stream which then degrades the environment. So the environment actually has a double whammy. A, it's got resources extracted from it, and secondly, it has waste that's added to it. And at a very high level, this is kind of one of the challenges that we have. And when we were, say 100 years ago, the relative populations and the wealth of populations was relatively low, and therefore the amount that we extracted was relatively small, and the impact on the environment was relatively low. But now, as the populations are growing and we're getting richer, actually these are becoming critical. And in a sense, this is one of the classic systems traps of the tragedy of the commons, in that we've got a common resource that we're all drawing from, and yet we are degrading that, and as they get more commoners around, we got to work through that. So we've got to rethink about saying, how do we actually change this very high level float so that we stop putting as much waste in, stop using as much resources. And the particular one that we want to talk about today is basically the whole issue around how do we mitigate the amount of carbon that's going into the atmosphere to stop doing climate change. Now, Eric, you and I both think of looking at systems as a way of looking at it, and this is the highest level systems. But I wanted to start off our conversation with thinking about, why do you think systems engineering is a particular way of going forward? What are some of the strengths that you see of why we need to pursue this particular approach?
Okay, thanks, Malcolm. So I think the net zero challenge has some very specific characteristics that call on us to think differently than we have traditionally, particularly how we've traditionally thought in the energy system. I think systems engineering and importantly systems of systems engineering bring various processes and tools and techniques that help us in a number of ways. So I just want to highlight 3 or 4 of those this morning. And the first of those is system engineering helps you organize and work with complexity. And the way that it is that, in my mind, is that it helps you identify the interactions between components in systems, which may not be visible or they may not be obvious, but they could be key to understanding what solutions are possible, as well as the solutions that are viable. And the solutions that are possible are not necessarily all viable. They might not all work in practice. And systems engineering helps you identify which ones will actually work in practice. And importantly, the way that it achieves that is that it provides the structures that enable the information flows that in turn enable good decision making. Now, when we talk about complexity, I think we can argue it's arguably net zero is probably one of the most complex things we've ever done anywhere. So it's really quite important to be able to address that complexity in a systematic way. A second thing that I think is a strength is that it helps you align the varied and disparate interests of the parties that are going to have to act together to achieve the desired outcomes. And importantly here, what system engineering does, it explicitly enables you to identify and engage with the right stakeholders to be needed to define and focus on a shared purpose. In this case, achieving net zero. And in the case of climate, we are going to have to bring together parties that have never worked together before and focus them on that shared purpose. A third strength, I think, is that system engineering helps you deal with the fast pace of change that we're experiencing. We all are aware that technology and society is changing at a great pace. Some of these are digitally enabled. Many of them are being executed by new players to the field. And I would argue that traditional methods aren't going to be adequate because they rely on timescales that are too slow. So when it comes to implementation, learning and adaptation must be built in and responsive, not added on in retrospective. And I would say system engineering helps you achieve that. And the fourth area that I'd highlight this morning is that system engineering helps you manage in circumstances of great uncertainty. Innovation and disruption are two sources of uncertainty, but also how people are going to engage with change is another and a very important source of uncertainty as we seek to undertake transition or transformation. And implementation of solutions that are being deployed in circumstances such as this should accommodate experimentation and be responsive. And the iteration and agility that system engineering bring to the table, I think, are going to be critical to many of the types of transition that we're going to have, or transformation that we're going to experience as we move forward in net zero. Now, I don't see system engineering as some sort of magic solution. It's not a silver bullet, but I think it does offer some really strong support in helping to deal with big problems, and net zero is definitely one of them. Like one of my colleagues says, it's getting to net zero is not like fixing an airplane in flight. It's like rebuilding the airplane while it's in flight. It's a very, very substantial program, one that we've never experienced at that scale before. Now, Malcolm, I think you have some other thoughts on the strengths of system engineering and how they might help us here.
Yeah, thanks, Eric. So these are basically very similar concepts, but just slightly put in a slightly different way. And for me, one of the things that I've recognized is that it uncovers unexpected behavior. And you kind of think as well, surely everybody's acting in a rational way. Why do we get these unintended consequences? And what becomes clear is that a lot of people are acting in good faith, but they're acting with what I call what's been termed bounded rationality. And bounded rationality basically means they only get a limited perspective of the whole system. So they're responding to cues and information, but from a limited perspective. That's where the word bounded comes from. And from that limited perspective, they're then making decisions. But those decisions often, you can have a set of multiple parties all making decisions that seem good from their particular perspective. But when you put them all together, you realize actually this is going to cause a major problem. And in fact, we can see this, just very simply, is that each country wants to, burn coal and fossil fuels to be able to do their particular economy. And in a local sense, that makes actually sense. But when you look at it at a global sense, that's a real problem. And that's why we talk about bounded rationality. Is actually, to me, is one of the key aspects of systems thinking, which actually we need to be able to deal with. The next one that I would like to talk about is that systems engineering allows you to have a multiscalar perspective. You can basically zoom out or zoom into the problem, and that allows you to then cope with the particular issues at hand, but also be aware of what some of the implications and ramifications are. And we'll show some of that coming later on. And then the third one, which I think is a very powerful side of systems engineering, if you do this explicitly, is we can actually design from the get-go self-adapting systems, so that systems can basically self-correct as you're going along. So to follow Eric's analogy, is basically we've got a managing how we reconstruct this aeroplane in flight when suddenly a bird hits the plane or something else happens or something unexpected happens. We can design a self-adapting system that allows us to do it. And to me, those are some of the key strengths. Eric.
So when we believe that with systems engineering we have an approach that'll help us. So now we want to turn to net zero, and think that there's some really important issues there to be considered. So Malcolm, I think you're going to start the conversation on this.
Yeah. So this is basically some data that we've got from Bayes, which looking at the UK emissions. And to me, there are a couple of really interesting high-level things which jump out straight away for me. One of it is that a lot of it is, a systems problem. So if you look at things like the energy supply, being able to take that to net zero, looking at transport, basically how do we remove the carbon out of that, basically how do we move from fossil fuels to alternatives. And we look at businesses and residential, basically a lot of that carbon is around space heating. We know what a lot of the solutions can be, and therefore the technical solutions are basically largely done. The challenge is really to say, how do we actually rejig our systems so that those low carbon solutions are actually attractive and actually will come to the fore. Yes, there are about 20% of the problem is really hard. Things like long-term storage is going to be really hard. How we deal with certain aspects of dealing with things like creating steel and cement, because it's a chemical process that's involved in there. Those are going to be some of the hard issues, but at least the 80% is relatively straightforward. One of the characteristics of that 80% is that fossil carbon is actually a greater priority in my mind. It's that we want to stop introducing new carbon into the biosphere. And the faster we can do that, the more time that gives us to deal with the somewhat harder problems of things like how do you deal with agriculture, the changes that they need to do with agriculture. And then the third one is basically, again, just going back to that earlier slide I had, is to say that actually CO2 and climate change is part of the bigger problem of resource depletion and environmental degradation. So, and we need to be aware of things like, we've got to not provide solutions to the carbon problem, which then lock us out of solutions of dealing with things like fresh water and land change and biodiversity and other issues. So yes, this is a big problem, but it's one of a suite of problems that we need to be aware of. So that's from a very high level perspective. Eric, what are your thoughts on this?
So I have just some observations to make on maybe more on how we get to net zero rather than what we have to do to get there. And I think one of the points I think it's important to make is that this is not a nice, straightforward, linear problem with a clear objective that we can easily map a roadmap to achieve. There's actually more than one way that you can achieve zero, and you can do it badly. So we can reach net zero greenhouse gas emissions, but we can do that. We can either do that effectively and productively, in other words, at a reasonable cost, or we can do it very expensively. And we can also measure the how well or how badly we do that in terms of the types of social and economic impact that it has. So I think we need to be mindful that we want to find a good way or the best way to achieve net zero. I think in the discussion that goes on in the sector broadly, when we talk about achieving net zero, we seem to focus on what we need to do. So we talk about it in terms of technologies, such as do we use this much nuclear? Do we use this much renewables? Do we decarbonize transport? Do we electrify heat? These are the kinds of questions, but they're much more about what we are going to do to decarbonize, and less on how we're actually going to achieve the types of outcomes that we need. What kinds of decisions and processes and trade-offs are we going to make? Another important consideration, I think, is we tend to express our thinking on how to get to net zero, or what we need to do to get to net zero, I should say, in terms of a problem that we think is well defined. Well, that is true. There is a clear objective, which in the UK is embedded in legislation, but we have to bear in mind it's not just the nature and combination of solutions that's going to change as we move forward. The definition of the problem itself will change as we learn, as innovation happens, and so on. And in fact, as we respond to unexpected events, things like pandemics, for instance, change the description of the problem that we're trying to solve as we seek to move to net zero. So you have the solutions changing, and at the same time the problem is changing. And it's also very important to acknowledge this is not just a technical problem. It has technology is certainly a key factor, but we also have to think about things like value propositions and business models and regulation and policy and so on. And very importantly, the relationship between this sorts of change and what that means for society generally. And in the some work we've done at the Catapult, for example, we talk about decarbonisation, but in order to get to net zero, some of these implications are going to be very strong, and that they're going to affect things not just like power and heat and transport, but things like aviation and diet and land use and other factors that we will need to that will present very significant challenges. So so far we've shared some thoughts on the challenge we face in terms of net zero. We've shared some thoughts around how systems engineering might be able to bring some help to as we seek to respond to that challenge. So how do we pull it all together? So we're going to look a little bit more detail at some and how we actually achieve change. So Malcolm, over to you.
Right. So what I was going to start off with again, is I seem to be doing the high level stuff, is just think about it at a very high level. What are some of the two big changes that are going to have to happen? Now, there are probably about 20 or 30 big things that are going to change, but I've just picked on two because they kind of are an interesting way of thinking and phrasing through the problem. And Eric will then move on to some of the detail around that, and we'll play through how do these particular things play through. The first interesting one is that electrical generation is going to have to move from a commodity play to an asset play. So what I mean by that? Well, at the moment, if you've got a gas-fired power station, most of your cost is associated with the fuel, the gas that's put in it, not in the cost of the power station itself. And therefore, your costs are associated with how much energy you actually produce. And therefore, and that's great, because if the demand goes down, basically the cost of generation go down, and they basically track track that, and that's really good. And therefore, a commodity selling kilowatt hours is really a good way to go forward. The problem is, as we move to renewable generation and even nuclear to a certain extent, is that most of the cost is not in the fuel. Solar is, the sunshine and the wind is free. Most of the cost is actually in your asset base. And so therefore, the cost, we basically moving from a short-run marginal cost to a long-run marginal cost. And that means the business models that we have to change and evolve. Now, what we've started to see is ways things that can try to do that. And so things like where we have a contract for difference is basically a way of kind of guaranteeing a minimum price. But that's really a sticky plaster approach. And if we was to start now with the renewable system, that's not where we would start. And so therefore, we have to think about where is a good place to end around how do we actually pay for generation. The second side of it is if you look at the sales and the selling of electricity, again, I believe you're going to move largely away from a commodity system to a service provision. The reason for that is because a lot of the service that we're going to be providing, say for instance, if you look at mobility or heating or others, again, you're not actually, the consumer is not interested in the energy itself. It's rather interested in the service that you provide. And because things like electric vehicles and heating has a built-in storage capacity in them, it actually means that you can flexibly deploy the amount when you produce the energy for those particular services. But if you're going to do that, I don't think many of us will be wanting to sit down and actually watch what the prices are doing. So I think there's going to be an interesting group of people, and we're already starting to see this, where people would say, for instance, when you lease your electric vehicle, part of that you actually lease a certain amount of miles associated with it, and basically they'll cover your energy costs to do that. And I think this is going to be, in transport, is going to make it's clear. Also, if you're looking at heating, it means that it's a way of retrofitting the home and then covering the energy to provide your comfort level. A service model seems to be a natural way of going forward with that. But the problem is that now creates a whole lot of particular challenges, as to say, how do we have an energy-enabled service without buying a commodity of energy? How does that actually play through? So, Eric, I think you're going to take a little look at this, especially around transport, to see what some of the challenges around that might look like.
That's right, yeah. So if we move, there we go. So what we thought it would be perhaps helpful to try and bring this together by looking at a particular example. And the starting question is, how do we decarbonize road transport? And the answer that this is a question, I guess, that's very visible to many of us as we hear increasing amounts of conversations around electric vehicles and providing the necessary infrastructure and so on to support them. And largely that question, or in some cases at least, that question gets thought about in terms of, well, how do you replace internal combustion engine vehicles with electric vehicles? And I think what I might argue about this perspective is that it takes a tailpipes emission view as opposed to a systems emission view, and that's what we want to think about a little bit as we try to answer this question. So if we start with that, and then we look at well, let's just think a little bit more broadly from a systems point of view. We very quickly realize that this type of change, replacing internal combustion with electric vehicles, you start to find that there are actually a substantial number of interactions with other parts of the system or the system of systems. So obviously, if you're going to be charging vehicles, electricity infrastructure is going to be very important. You're going to need to have the right kind of capacity in the right sort of place at the right time to enable consumers to get a good experience from using this electric vehicle. And there's other types of implications around certainly the charging infrastructure, and importantly, can you give a good experience to consumers because they come to it with an expectation. Anyway, we think about that, and then we think, well, actually, if you are looking at what consumers are trying to achieve, actually they're trying to travel. So do we need to look at interactions with other forms and approaches of low carbon mobility? And this could bring us into the question, well, do you walk? Do you take a bicycle? Do you use public transport? Do you use autonomous vehicles? What other kinds of business models might exist for allowing people to travel from A to B in a low carbon way, which may or may not involve them owning an electric vehicle? So you can see that we're building out to see the additional interactions that need to be considered as we think about the question about decarbonising transport. And then, as was suggested earlier, transport doesn't exist in a comfortable, isolated bubble. When you start looking at questions of electrification, for example, you come up against other vectors such as heating. So you need to take into account not only the interactions within the transport system, but those interactions with others. And I've used the example of heating here. So if we look at this complexity and try to think, well, how are we going to decarbonize road transport? Maybe coming back to the point that Malcolm raised earlier, what if we wanted to understand the implications of an energy-enabled mobility service? What are the decisions we would have to make, and how might systems engineering help us make those decisions on the journey to net zero around this particular type of question? So I think Malcolm's going to solve the problem for us now.
No, I'm going to just basically kind of identify some of the aspects of it. Now, the key thing about decision is to say you've got to think about not only who's the decision maker, and in this case we're going to think about mobility service providers, but also where's the information coming from, who's influencing the decision. Because in a system, it's basically an interaction between multiple people, and it's about flows of information and how do we restructure those and get those right. So what I'm going to do is just basically work through, again, a very quick way, assuming now I'm making some broad assumptions that this is a mobility service for a electric vehicle to a customer at home. We are obviously where it could be for a car club, it could be for multiple other ways. I'm just going to take this particular example and take it forward and run through a number of decisions that have to be made by the service provider and think about who the counterparties to this decision. So obviously the very first decision that needs to be asked is to say, how do we provide the best service for a customer? So we've got our energy-enabled service provider in the center, and obviously that's going to be dealing with a customer, and that's going to think about, from marketing and other things, you can say, okay, what are the types of things that a customer will need to have? Underlying that, there are a whole lot of subsidiary questions, and the next one was this obvious one is to say, okay, what is the best type of vehicle to be using? Who's the manufacturer we're going to use? And OEM is the motor manufacturer, for those of you who don't know the terminology. So here we can see is now this decision relies both on what the customer preferences are, but also what deals you can actually, and what vehicles are actually available from the OEMs. So we can start to see this is getting slightly more complicated. The next thing is to think about to say, okay, what type of charge point is the right way of charging it? What is the best way of doing it if you're going to deliver it at home? And that's dependent on what is the customer preferences are, what the OEM actually allows you to, in other words, what type of plugs can you put in? Are you basically a Japanese or a European variant or a US variant? There are different types of charge point structures you can put in. Now it starts to get a little bit more interesting, and that is to say, do you go for 7 kilowatt, which is basically the fast charge now, or there's definitely a trend to look at a 3-phase 21 kilowatt for fast chargers. But as soon as you go to 3-phase, that now means that in most cases, you actually have to change the connection coming into your home. And that now means that you have to start interacting with your local DNO to be able to enable you to have a new connection to come through. It also depends on whether the car can actually do it, whether the charge point can actually do a 3-phase variant with it. So once you've done that, you then might say, well, hold on, 21 kilowatts is quite high, and if you're doing a lot of houses in the same area, you might suddenly find that you're actually going to need a network upgrade. And now the question is, who pays for that network upgrade? And this is where people like Ofgem come into play, because they'll decide whether you have a shallow or deep connections charge. And basically, a shallow charge basically says you just pay for your local, you pay the network for a local upgrade. Whereas a deep one says that you actually have to go to the higher voltage levels and costs you substantially more. So you might suddenly find that to produce your 21 kilowatt upgrade, because you're the last person into of that capacity, you might trigger it where you actually have to pay a substantial amount of money to the DNO to do upgrade. And that's all defined by Ofgem. So Ofgem now has to be careful about thinking about how do they set the rules of the game for the DNO so they can enable these types of services going forward. And then we get into the really thorny question of who supplies the energy. Now remember that as the energy supplier, the energy-enabled EV service, they're not selling energy, they're selling miles of traveling, but we still need energy to come from it. So you could think about saying, okay, maybe you talk to the energy retailer that the customer happens to be using at the time, and maybe you can set something up. But do we have something like 20 different retailers in the UK? And that means, do we force the customer to change retailer, or do we allow them to choose any retailer for all the other services and basically go with a separate retailer? And what are some of the challenges around that? Actually, what you might decide is that if you're an energy-enabled mobility, and if you're very large, actually what you might discover that actually because of the scale that you can get to, that you may, as the energy-enabled mobility survivor, want to supply the energy. You might have your own contracts with say, solar farms and wind farms, and because you've got a lot of flexibility in the way that you do the service, you may want to bypass the energy retailer for that particular aspect. But now you need to be able to interact with Alexon to see whether there's actually a code, and there's a P379 which is going through to say, can you actually have a dual supplier? So can an individual retailer have a dual supplier? And that's largely just decided by Alexon and also by BEIS, who basically sets the larger policy around this. So BEIS now has to be aware of that. You might have not only different suppliers because they might be green suppliers, but they're actually providing different types of services. So BEIS now starts to get involved in this particular type of discussion. And then a secondary question is to say, if I can supply my own meter just for this, and then I use supply the energy retailer provides all the balance of one, can I use the smart meter just to be able to piggyback onto the existing smart meter? And again, this starts to interact with the DCC, which basically provides a communication service. How do I do that? It also starts to interact with Ofgem and BEIS and Alexon and the energy retailer, because the energy retailer essentially owns the meter during that particular phase, or they put the meter in. Are you going to be allowed to do it? Now, one of the questions, of course, is that often the smart meters don't actually necessarily monitor a separate circuit. Now, you want to have a separate circuit, so how does that start to come into play? And this seemingly trivial question starts to get really nasty. And then if you are doing that, what about other services? What about other energy service providers? Say, for instance, with heating, how does your particular one interact with that? Now, where this comes in is that, for instance, the smarter meter allows for 2 suppliers, but you potentially could have 3 or 4 suppliers. How do we manage that particular flavor going forward? And then a really interesting question is, am I regulated? Because I don't actually sell energy, I'm actually selling mobility. So do I fall under the same regulations or not? And this is a question for BEIS and for Ofgem. And then the last one is to say, do I provide flexibility services? And the answer is, obviously, I want to. So now I have to start interacting not only with the DNO and their emerging flexibility services that are coming forward, but also the ESO. And then the question is, am I a regulated supplier, and do I have to go through to Ofgem to get a license or not, even though I'm not actually selling energy per se? And the last one is, do I need vehicle to grid? And actually this starts to impact a lot of the decisions that you made earlier on in terms of the charger that you used, the interactions with the different people in terms of what are the contractual and the technical arrangements that you need to put in place. And then the last one is to say, could I do vehicle to home, which basically allows you to do flexibility. And again, now that brings in the retailer front and center into space, because you're potentially providing energy in for that. And then what is it that I don't know? And so this is one of the hardest decisions that you've got to make, to say, what are the things that we're missing? And I think that's one of the challenges that a systems approach tries to take. Eric.
Okay, so from here we can move forward, Malcolm, please. Yeah.
Yeah. So basically, what we've been doing in Leo is Project Leo is looking at a way of how we can actually manage these type of system transitions. And what you do is you have multiple little interactors, and you have flows between them. And that's basically what I mean by a system. And we're trying to develop new systems. And so we developed a technique where we basically understand the societal need, which is providing, say, for instance, mobility. We think through a theory of change of how we're going to be doing that. We then build up a minimum viable system to test how the different interactions actually work. And from those minimum viable systems, we then measure and understand the processes, and we learn from that. And the key thing is that with the systems perspective is that we can then adapt both our minimal viable systems and my theory of change, and so that we better understand what the societal need is. And so this is a way of actually using a systems approach to build in a self-adapting system so that we can learn through things and overcome both those bounded rationalities and also the unknown unknowns. And we can do this at pace to start off with, because we can start with a small scale and then rapidly build up once we know how the whole system works. So that gives us a whistle-stop tour. Eric, do you have any concluding thoughts?
Well, I'm certainly mindful that we've taken our time, but I guess my concluding comments are that we've tried to paint a picture of some of the nature and attributes of and importance of getting to net zero. We've shared some thoughts around the role that system engineering could play in helping us achieve that, and now we've tried to bring it together in a very, very quick way to illustrate that through an example. So I guess my hope is that we've been able to give you some indication of how system engineering could play a very key role in helping us achieve not only climate objectives, but being mindful of the need to achieve economic and social ones as well. And with that, Helen, I think we're for questions. I think.
Thank you very much. It's an impossible topic to explore in but 35 minutes, which you had to present. So I hope that the people who are listening and saw your slides did manage to glean a lot of valuable information from it. We certainly have a lot of questions that have been coming through. So I'm going to ask some questions now. So if anybody has questions or comments, please do pop them into the chat pane. And I'll be able to pick them up. So someone asked the question, is system thinking prior to system engineering? Do you want to comment on that? What should happen first? Should we think about it before we engineer it?
So if I may, oh, pardon me. It's one of my favorite subjects, and I think the point is you need to do both. And I think there has been a lot of system thinking done in my view. There's been the entry of the term whole system thinking has entered the language, I think, and certainly in the energy sector as we look at transition. But I suppose from a personal point of view, I think there comes a point where you need to act, and I look at the timeline of, we're 2020, we're at 2050, and I think we have thought about. I think we need to continue thinking about it, but we all need to act, and this is, I see system engineering as being the structure that enables us to act. But we don't, but it has the benefit of meaning that we're just acting without thinking. I think it gives us the opportunity to bring two things together. But I'm very keen to move just from thinking to acting, which is, I guess, part of the explanation of why I've become interested in system engineering as a way forward.
Yeah. Okay, I'll move on to another question then. Someone asked the question: Will be getting to net zero by 2050, will it be soon enough, do you think? Do we have the tools in place now? I'm going to add in another question here, which is, how can our system engineering tools cope with chaotic systems, such as non-linearities, positive feedback loops? Malcolm, would you like to take that one? Or take those, I should say? Yeah,
so my view is that I think we could actually decarbonize, in the UK, we could decarbonize the energy system by about 2032, 2033. And that'll take out a large amount of the carbon already, and that'll help us a lot. I think 2050 is too late. I think we need to go faster than that. One of the things is that systems are messy, they are chaotic, they are highly nonlinear, and so and also there are a lot of unknowns and unexpected pieces to a system and unexpected loops that you get. And this is why that last little those last slides that I talked through is where you actually build in a feedback loop into the system, where you actually learn from what's going on and then adjust the way that you configure the system. So you might be changing a policy, you might be changing the amounts that you pay for certain services. You've got to have a way of adapting on the fly. And this is where I think the strength of system engineering is because it can cope with those if you design it well. Often the challenge is that you then get delays in the system if you design it badly, and those delays can exacerbate some of those non-linearities. So you have to be careful in the way that you design those feedback loops. But I think to me, it's the only way that we can actually manage those really complex, non-linear, horrible problems.
Thank you. We saw the sheer complexity through the examples that you gave in terms of the decisions and the thoughts, the processes that need to be put in place to make an effective and sustainable change, such as decarbonising our transport system. And that's just arguably on the kind of technical side of it. The other dimension of it is more, say, the business side or the political aspects. So one of the questions we had was, how do we convince corporations and politicians to strive towards net zero when profit making and politics are simply too short-sighted for such large issues? Would you like to comment?
So I'll comment, and then maybe Malcolm, you can follow on. I think in the UK, the benefit of getting to net zero is being embedded in legislation where we are legally obliged to do it, and I think that clarity has been very helpful in the observations I'd make about industry generally. I think there does seem to be a focus on satisfying that because there's an obligation to do so. I think another thing that was really important recently was the Extinction Rebellion movement, which really galvanized people to again around the question of climate change, and I think that's had quite a substantial political impact. So between net zero and Extinction Rebellion, I think it really provides a huge amount of focus for us. I think then the last comment I would make, though, in the work that we do, we encounter lots of parties who seem genuinely to want to support the need and the path to net zero, but they just genuinely don't know what to do, and so they're looking for help into understanding how. What should they do to change their business, to transition their businesses, to transition their work, and so on to support the journey to achieving these kinds of outcomes.
So my kind of reflection is that actually the society is actually changing quite dramatically, and you can see things like vegan products coming through and actually being bought by a lot of people and actually becoming a lot more palatable, and therefore creating a strong business case for corporations to move in that direction. And so you can say, I think what government needs to be doing is enabling the regulatory environment to gently favour or at least allow for and then favour these new emerging business models that will help us as consumers get to net zero a lot quicker. That's on one side, and I think on the other side is that there are going to be corporations that are going to be really slow to the game, and the only way one can really deal with them is regulation. So, for instance, the regulation that no new internal combustion engine vehicles can be sold from, 2040, and that's coming back possibly earlier to, sometime in the 2030s. That type of regulatory push really helps shift the way people are thinking as well.
Okay, well, just to continue on the kind of people aspect here, but to move on to, say, everyday people, there's a question here about saying technical improvements are definitely needed, but without behavioural change, it might not be possible to achieve the goal. So how much of the social educational aspects do we need to factor into the systems engineering approach? Because there are lots of people, in the UK or globally, who are used to doing things in a certain way and may need to change. Would you like to either, Malcolm or Eric, would you like to comment on that?
I'm happy to start, if I may. So there's two things that I would say. First of all, from a systems engineering point of view, I think one of the key strengths of it is that it focuses on needs, and it comes back to I made reference to this idea of shared purpose, and I think you have to acknowledge and center your thinking around the fact that you actually are making this transition happen for the benefit of society, for the benefit of the citizens and the people that live in society. So as you think about what you're trying to achieve with your transformation, with your transition to net zero, people need to be a key stakeholder whose needs are being considered as you define the types of changes that you're going to make. In terms of the behavioral side of it and the need to engage with people and bring them along on the journey, I think there's a shift that needs to happen. I think historically we said this is the energy system and we need to get people to do what we need them to do to support the system. I think there's being a change, which is, well, these are what people need, and the energy system needs to respond to what people need. From the energy system. So there's a shift in paradigm almost. And in the work that we do in the Catapult, we actually have a group who's focused explicitly on this question about how do you understand and support the consumer, the citizen, their changing relationship. Their changing relationship with energy. And one of the things we've discovered there, and then my last point, is that if you ask people what they want to have happen, or how they relate to energy, or for example how they heat their homes, they will tell you a certain answer which they'll believe to be true. But what we have found is you actually have to engage more deeply than that. You have to model and test and to work in what we've called our living lab, actually to understand how people really do engage with energy. And I think that would be true not just for the work that we've done around heating particularly, but also in terms of the idea of transport and travel and mobility that we've talked about before. So I think it's important to engage really quite deeply to understand the kinds of things that people want from energy. But it's absolutely central to making this happen. It won't happen unless people support it. As one of my colleagues says, people have the veto on net zero. If they don't want to get there, it won't happen. Sorry, Malcolm, I think I interrupted you. Sorry.
No, I think that's absolutely spot on.
Okay, yeah, I guess someone like me who I try and minimize my own personal carbon footprint. I just get so frustrated when I can see people like Malcolm saying, yes, we can achieve a decarbonized energy system by the mid-30s, but on the other hand, it doesn't seem like much is being made to educate, to very widely educate everybody about the need for doing this, what people can do, etc. And you mentioned XR, and it's great to hear that Extinction Rebellion is having an impact, because at the moment there is a global campaign, but it's not being reflected in the media per se, or if it is, it's in a negative impact. So it's nice to hear that from you. But can I pose a question to Malcolm? This is a question on what role can local authorities play in systems engineering, and what is their position between national government and individuals? Yeah,
this is a really interesting question, because I think this is something that is actually a really hard challenge, and something that Eric and I talk about quite a lot, is to say, what is the role between national, local and individual? My particular perspective is that actually at the national level, we kind of have to set the direction of travel right, and we have to get some basic principles sorted out, and so that people know what they're working towards. But then when it comes to a local deployment, I think it's actually the local authorities or local councils often have a much better understanding of what the local needs and opportunities are. The challenge that we have is that because of various restructuring of the finances within councils, funding cuts, etc., is that there is actually not necessarily always the skills base there to be able to implement it. There might be the will, but there might not be the capability to do that. And so one of the things that I'm particularly keen on doing is to say, could we actually look at providing material to enable a new cadre of people to come in to support local authorities in making those decisions on things like, how do you create a local, a zero carbon energy plan? How do you actually, turn, a lot of councils have made a zero carbon or climate change commitment. How do we actually enable that to happen into practice? We're particularly lucky that in Oxfordshire we've been working quite strongly with both our county council and the district and city councils, and working in Project Leo about how do we actually develop the tool sets and the data collection so that we can enable ourselves to work towards that local implementation of a zero carbon future. So in my particular perspective, I think the local authorities are absolutely key in this place. But we need to provide a cadre of people to support them, and there's going to be finance behind that to actually enable that to happen. And I think there potentially be innovative ways of doing that, but that's going to be key.
Yeah, I agree. We only have a few minutes left, and I want to squeeze in two questions, so please no long answers to these. But first, question to Eric. Are there any key differences in systems thinking to achieve net zero versus the 80% reduction in emissions, which is UK legislated goal before net zero?
Yeah, so we've done quite a lot of work in the Catapult on this, and we've published a paper which addresses exactly this question called "Innovating to Net Zero." So I would encourage you to maybe check the website. And it addresses specifically this question. Helen said, "Don't make a long answer," so I'll make a very quick one. What we've discovered in our work is that you can apply I guess what we've called the conventional methods almost of to get to roughly 96%, and then there's the last 4% is really tough. And this is where I made very brief passing reference in earlier comments about some of the things that really come to play here, and they do touch on what you're referring to. Questions about land use, particularly around aviation. How do you which touches on the social issue of travel and people's expectations about travel, and diet is another one. Basically, no beef would be a way to say that. So there are some. It isn't a technical problem at all. It really does start to impinge on people's lifestyle in a quite a significant way. Technology is seen as an alternative to that, and people talk about direct air capture as another way to get there. But I think ultimately people are going to have to contribute in a way which will affect lifestyle. But I would encourage you to read the report. It does provide some depth to that discussion.
Okay. On the subject of direct air capture, I'm going to ask the last question. What consideration is being given to carbon sequestration? Does it have a role in our attaining net zero?
So my particular thought on this is that it's kind of like a sticky plaster. It allows us to get going through, but it won't actually cure it. It's not a cure. We can't do, there's very interesting work being done on what is the total amount of carbon sequestration space available. And what's interesting, there's enough for the UK, but there's less than 5% available for the world. So as soon as you start looking at a global level, there's just not enough space to store the stuff. So my kind of view, it's a temporary, transient technology, which we're probably going to have to need in the short term. But it's something that I'd rather cure the problem if we can, rather than trying to apply the sticky plaster at the end.
Eric, would you like to comment?
I'm afraid I would agree with Malcolm's comments. Such, I think it's perhaps necessary but not sufficient, I suppose, would be the way I would summarize.
Okay, well, thank you both, Malcolm and Eric. Thank you very much for your presentation, and thank you to everybody who joined and gave very good questions, and apologies again if we weren't able to answer you, to ask your question. Just let us say thank you to each other and to the speakers by waving and saying goodbye. Goodbye.